Problems on unit 4, Fourier transform. So first problem is obtain Fourier transform of unit step. So x of t is equal to u of t so unit step signal we have to draw here. So this is unit step signal and it is defined as u of t is equal to 1 for t greater than equal to 0 and it is 0 for all other values. Okay. Now according to the definition of Fourier transform, x of f is equal to minus infinity to infinity x of t e raised to minus j 2 pi f t dt. So the value of x of t is equal to u of t is 1 from 0 to infinity. So x of f is equal to 0 to infinity 1 e raised to minus j 2 pi. Now we solve this integration. So e raised to minus j 2 pi f t minus j 2 pi f 0 to infinity. So it is equal to e raised to minus infinity minus e raised to divided by. So what is, since e raised to minus infinity is 0 and e raised to 0 is 1. Okay. So equation becomes xf is equal to 0 minus 1 by j 2 pi f. It is equal to 1 by j 2 pi f. Therefore u of t Fourier transform 1 by j 2 pi f or 1 by j omega. Okay. Now next problem is obtain, second problem, obtain Fourier transform of x of t is equal to e raised to minus 8t u of t. So e raised to minus a t is exponential function, but it is decaying exponential function. So we draw the diagram first. So it is, first we write here, it is decaying. There are two exponential functions. One is growing exponential and second is decaying exponential. So this exponential function is decaying exponential function. or we can say signal. So we draw the diagram. So now, according to the definition of Fourier transform, x of f is minus infinity to infinity x of t e raised to minus j by f t d. Now if the given signal is multiplied with u of t, then limits of integration will be from 0 to infinity. Okay, because u of t exists from 0 to infinity and its value is 1. So x of f is equal to 0 to infinity e raised to minus at so it is 0 to infinity minus t is common a plus j 2 pi f into dt. Now we take the integration of this function. Zero to infinity. Now we substitute these integration values here and we get therefore x of f is equal to so Fourier transform of this function is 1 by a plus j 2 pi f. So this type of problem was asked in exam for 4 marks. Now next problem. Obtain Fourier transform of rectangular pulse. So x of t is equal to a and sketch the spectrum. So the rectangular pulse of amplitude a and width t here the pulse is of amplitude A and width T. So we will draw the diagram for this. It is x of t is equal to A rectangular of T by capital T. It is A, it's minus T by 2, 0, T by 2. So this is amplitude A. Now according to the definition of Fourier transform, x of f is equal to minus infinity to infinity x of t e raised to minus j2 pi f dt. Now here xt is a. Here we write here x of t is a and it is from minus t by 2 to plus t by 2. So equation becomes x of f is equal to integration minus t by 2 to plus t by 2 a e raised to minus j2 pi f dt. It is a by minus j2 pi f e raised to minus j2 pi f t minus t by 2 to t by 2. So we will solve this. So it is equal to a by minus j2 pi f. It is constant. It is j pi ft minus e raised to so by solving we get a by pi f. This is equation number 1. Now next is according to according to Euler's identity, sin theta is e raised to j theta minus e raised to minus j theta divided by 2j. And here what is theta? Here theta is j pi f t. So our equation becomes x of f is equal to a by pi f sin of pi f t. This is equation number 2. Okay. Now multiply and divide by t. So f of x of t is equal to 80 sin of pi f t this is equation number 3. Now in equation 3 sin pi f t divided by pi f t is equal to therefore x of f is equal to 80 so Fourier transform of this is Okay, now we have to draw the amplitude spectrum for this. So amplitude spectrum for this is, it is 0, it is minus 1 by t, plus 1 by t, it is minus 2 by t, minus 3 by t, plus 2 by t, plus 3 by t. This is a t. This is amplitude spectrum. It is x of f magnitude. So we have equations of 0 is 1. So at of 0 is a into t, because this value is 1. Now the sinc function will have a 0 value for the following values of ft. So sinc of f of t is equal to 0 for ft is plus 1, plus minus 1, plus minus 2, 3 dot dot. That is f is equal to plus minus 1 by t, plus minus 1 by 2t, 2 by t, plus minus 3 by t dot dot dot. And the phase spectrum is 0, is not shown here because it has a 0 values for all the values of f. Now the next problem is obtain Fourier transform of signum function. So x of t is equal to hgn of t. So diagram for this is, it is t, this is up to minus infinity, minus 1, plus 1, up to plus infinity, this is 0. Now the signum's function is given by this figure. Okay, now mathematically signum function is expressed as sg on n of t is equal to, it is either plus 1 or minus 1 for t greater than equal to 0 and for t less than 0. Now in terms of unit step, signal function can be expressed as x of t is equal to hgn of t is equal to 2u of t minus 1. This is equation number 1. Now we will draw the diagram. It is t, 2u of t minus 1. So this function is hgn of t, this function is 2u of t minus 1, and its subtraction, that is its output, is so this figure is hgn of t equal to 2u of t minus 1. Okay, now differentiate equation 1. We write here differentiating equation 1. So d by dt of xt is equal to d by dt of 2u of t minus 1. So 2d by dt of u of t minus d by dt of 1. So d by dt of x of t is equal to 2d by. Now derivative of unit step is what? Derivative of unit step is delta function. So you can write here that derivative of unit step is delta function. So d by dt of x of t is equal to 2 delta of t. This is equation number 2. Now taking the Fourier transform of equation 2, taking Fourier transform of equation 2, we can write, so Fourier transform of delta of t is 1. So therefore j2 pi f x of f is equal to 2. Therefore x of f is equal to 2 pi, so it is 1 by j omega. Therefore x of f is equal to, we can write 1 by j pi f. So Fourier transform of this is 1 by j pi f or 2 by j omega. This is the Fourier transform signum function.